There you go.
All right, gentlemen, this is your test correction walkthrough for the fractions and decimal unit 3 test. So we're going to start right off the bat with question 1A. So whenever we're subtracting fractions, we want to have common denominators, but also more importantly, we want to make sure that we're working with improper fractions. It's just easier to subtract them that way. So we can go from there. So if we want to say this into an improper fraction, we multiply and then add. So as an improper fraction, this would be 20 sixths. So then we're at 26 minus 2/3. So just like anytime we're subtracting fractions, we want to have common denominators and multiply that by 2, multiply that by 2. So now I'm at 20 sixths minus 4 sixths equals 16 sixths. Convert that back to a mixed number. 6 goes into 16 twice. So I'm left with 2 and 4 sixths, which can be simplified to 2 and 2/3 by dividing these both by 2. Next up, an addition. Now you can approach this two ways. You can convert to mixed numbers or to improper fractions and add, or with addition, you can just park your whole numbers off to the side. So 2 plus 1 equals 3. Kind of keep that self-contained as a separate problem, and then add 5 sixths plus 3 sevenths. So we have to find a common denominator, and we're just going to simply multiply by 7, multiply by 7. Whenever you do to the bottom, you do to the top, by 6, by 6. And now I'm adding 35 40-seconds plus 18 40-seconds, which equals, Mr. Moore, our human calculator, 53 40-seconds. 42 goes into 53 once, and we're left with 11 40-seconds. This is simplified. All you need to do now is add your whole numbers that you parked off to the side earlier. So we're going to add 3 plus this. So this is just 3 plus 1 and 11 40-seconds, which equals 4 and 11 40-seconds. Over here, now we're going into some multiplication of fractions. For this problem, you want to pre-simplify first. So we're gonna take these two numbers and we're gonna divide them both by 3, and then that's going to be rewritten as 1/7 times 1/3. With multiplication of fractions, you just numerator times numerator, denominator times denominator. And this equals 1 over 21. Now, if I hadn't pre-simplified that first, I would have ended up with 3/7 times 1/9, and I would have had 3 over 63. These both can be divided by 3. If I divide this by 3, I get 1, and if I divide this by 3, I get 21. So you can see how the pre-simplifying works. It's much more efficient. When we're dividing fractions, again, we want to convert to an improper fraction. So this times this plus this. So 7 times 4 is 28 plus 2 is 30. So we have 30/7 divided by 3/9. Whenever we're dividing fractions, it's the same as multiplying by the inverse fraction. So we take 30 over 7 and we multiply it by 9 over 3. Notice that I can pre-simplify this. We've proven over here that it works. Divide by 3, divide by 3. That gets me to 10, and that gets me to 1. So I'm at, I divided by 3 to get there, and I divided by 3. So now I'm at 10/7 times 9 over 1, which equals 90 over 7. That goes in 12 times. 84. So we're left with 12 and 6/7. Thanks, Mr. Moore. Next page, a little bit more cumbersome, this one. So whenever we're multiplying decimals, not dividing decimals, multiplying decimals, you want to make them whole numbers. So I'm going to multiply this by 100, and that moves my decimal point over 2 times. So this is 3,142. and I'm multiplying this. I'm moving it over once. I'm multiplying it by 10. So this is 3,142 times 22. So if we're stacking this up, 4, 8, 2, 6, add my 0, and repeat. 4, 8, 2, 6. Add them up. 8 plus 4 is 12. Carry the 1. Gets me to 11. Carry the 1. 6 plus 3 is 9. And then nothing to carry over here. So I have 69,124. Now, think about this for a second. We know that decimals with a whole number are very close to that whole number, right? This isn't quite 2 and it isn't quite 3. It's just a little bit more than 2. This isn't quite 31 and it isn't quite 32. It's just a little bit more than 31. So you could make an estimation about what this answer should be. Even if I called it 30 times 2, I know my answer is going to be somewhere around 60. So if I end up here with 69,124, I know there's a problem. Okay, so there's a little bit more work to do. When you're multiplying by decimals, if you've made them whole numbers, you have to cancel out what you did originally. Okay, so if you multiply by 100 and by 10, you have to divide the whole thing by 1,000 now. And really that's just taking my decimal point and moving it 1, 2, 3 places. Now look, my estimate if I had done 30 times 2 was going to be 60. I'm really close to my estimate here. So I'm saying that my answer is 69.124. Now, does your answer make sense? Always be estimating. My answer does make sense because I know that my estimate was almost 30. My estimate, almost 60, was 60, and 69 is close to 60. So I know I'm on the right track. Does my answer make sense? Yeah, my answer makes sense. Over here. For this one, I'm taking 49.35 divided by 3.5. Now the thing with division is whatever you do, you don't have to cancel it out in the end as long as you increase them both by the same amount. It's the same principle as 4 divided by 2 equals 2. Well, 40 divided by 20 also equals 2. If I've multiplied them and increased them by 10 both equally, that reciprocal relation between the division stays the same. The proportion between the division stays the same. So I'm saying if I multiply this by 100 and make it 4,935, and this by 100 and make it 350, so now I'm 4,935 divided by 350 equals, the answer will be the same as 49.35 divided by 3.5. Now we're going to save a little bit of time with this one. We're going to just use our calculator. So if I say 4,935 divided by 350 equals 14.1. Well, look what happens if I say 49.35 divided by 3.5 equals 14.1. And now if I were estimating this, I could say, well, if I took, say I took 50 and divided it by 5, round up to 5, you know your answer is somewhere around 10. So 14.1 is pretty close to 10, therefore you know your answer makes sense. So my estimate was 10, therefore my answer is close and makes sense. Now, just marking your tests, a number of you, what you did was you ended up with something like 1.4 or 141. Make an estimate, figure out if you're in the ballpark or not. All right, over here we have, let's go to a sharper pencil. You doing okay up there, Mr. Moore?
Oh, yeah.
Oh, yeah. Big shoulder workout for Mr. Moore today, kids. Okay, so this is saying choose two different numbers and show them both in fraction and decimal form. We know that that fractions and decimals are both numbers. They're just smaller numbers. They're just less than a whole number, or a whole number in a little bit. So if I wanted to, say I wanted to pick the decimal 0.75, okay, now I want to convert that to a fraction. I write that as 75 over 100. Now this isn't good enough though, because I know that I can simplify this. And if I divide these both by 25, I know 25 goes into them both. I know 75 divided by 25 is 3, and 100 divided by 25 is 4. 0.75 equals 3/4. A number of you boys did this fraction work, but you didn't show, or did the answer, but you didn't show your work. You have to show your work. For this one, if I had the fraction of, let's say I had the fraction of 1/6, okay? Now to make that a decimal, I take my numerator and I divide it into my denominator. So this is 1 divided by 6. That's going to give me the decimal form. As long division, it looks like this. The 6 is on the outside, the 1 is underneath. I know that 6 doesn't go into 1, so I have to add a decimal point. Then I can add a 0. 6 does go into 10. It goes into 10 once. And 1 times 6, I'm left with 4. My decimal point also needs to be up there. I know 6 doesn't go into 4. I add another 0. I carry a 0 down. 6 goes into 4 how many times? It goes in 6 times. I'm left with 36. And now look what's happening. I'm in that infinite loop. Is this a terminating or a repeating decimal? Answer your question now. It is a repeating decimal. I know that this is going to keep coming 6 times. I'm left with 4, 6, I'm left with 4, 6, I'm left with 4. So this is 0.16 repeating. The 1 doesn't repeat, the 6 does repeat infinitely. You have an infinite string of 6s following that 6 there. You're just going to keep getting the same. 6 there, 36, left with 4. You get the drift. You're going to have 6, 6, 6, 6, 6, 6, 6, 6, 6. Okay. I want to pause that one there.